Okay, let's continue. We'll study the Pythagoras theorem. So, the problem is this. So, consider a right angle triangle ABC, and we have side lengths A, B, and C. So, we can ask, can we express C in terms of A and B? Can we express the larger side, the side opposite to 90 degrees? So, it is called the hypotenuse. So, can we express the hypotenuse in terms of the other side lengths? So, we'll try to do that. So, there are many proofs, there are many approaches, but this is one nice approach. So, consider a square of side A plus B. So, the arm lengths are A and B, and we want to find C in terms of A and B. So, consider a square of side A plus B and mark points as shown. So you mark points like this. So you have a square of side length A plus B, and you mark points PQRS as shown. So in a square of side A plus B, you mark points PQRS as shown. So the PQRS are chosen such that each side gets divided into portions of length A and B. So you have segment of length A, segment of length B, then segment of length A, segment of length B, and so on. So you get this diagram, right? So we can ask, is PQRS a square? Right? So we can ask that. So in the diagram, the outer object is anyways a square, and then you have points marked as shown. So, right. Note that we have four copies of the original right angle triangle. So there are four copies of the original right angle triangle, right? So So you have angles like this. So angle opposite to side length A, you can call this the double arc angle. So you have, so all these angles are the double arc angles. Angle opposite to side length B, you can call it the dashed angle or whatever. So this will be the dashed angle. And so we have angles are as shown. So note that this double arc angle plus the dashed angle, these sum up to 90 degrees. Hence, in PQRS, in this quadrilateral PQRS, firstly, all sides have length C, right? All sides are of length C because we have 4 copies. By construction, we have 4 copies of the original right angle triangle. So all sides are of length C and all angles are 90 degrees. So you can see that, for example, the angle at P is equal to 180 degrees minus the double arc angle minus the dashed angle, which is just 90 degrees. So all sides have length C and all angles are 90 degrees. Hence, indeed, PQRS is a square. Right. So now that we know that PQRS is a square, we will now we can consider the area of the original square ABCD. So note that area of the original big square ABCD is, this is A plus B whole square, the side length square, and the area of the square ABCD is the area of PQRS, which is C square, plus 4 times the area of each right angle triangle, 4 times the half AB. So this is C square plus 2AB. So hence these methods of computing the area of the big square, they must give the same result. Hence, A plus B whole square, the area of the big square, A plus B whole square is equal to area of PQRS plus 4 times area of each right angle triangle. A plus B whole square is C square plus 2AB. Hence, A square plus B square is equal to C square. Right. So we have the theorem. So the above equation gives a relationship between the sides of a right angle triangle. The hypotenuse square is A square plus B square. Hence we have this theorem, Pythagoras theorem. Consider a right angle triangle ABC. Then C square is A square plus B square. So this is the Pythagoras theorem, and that's all for this part. See you in the next part.